In this Mathematica Sessions video on Calculus and Linear Algebra 1, we're going to look at vectors. So this is episode 2 of the series on Calculus and Linear Algebra 1. And so I'm going to cover these 6 problems and their solutions in Mathematica and hand-calculated versions as well. So if you're interested in that, stick around. Now, if that's too elementary for you, then check out one of my other videos on mathematics and Mathematica. Okay. All right, let's begin. So our first problem here asks us to write the matrix form of the vector AB. So the arrow goes from A to B, so you can think of this as how to get from the point A to the point B, where the points A and B are given by 1, 3 and 4, 4. Okay, so what we want to do first is write the formula for this. So the vector AB is equal to basically B minus A. Okay, so there's our formula, and now what we need to do is actually calculate this. So to pull up a vector, I mean, I could just copy and paste here, but I should just show you how I got that. I can go insert, table matrix, new, and then I'll just go 2 rows and 1 column. Okay. And then I'll just put an equals here. So I'm just typing now, so I'll turn this into a comment soon. But now what I want to do is take the coordinates of the point 4 and put them in the rows. Okay, now I'm subtracting 1, 3. So I'll put 1 and 3. Okay, and then we want to make that addition. Now I could just copy and paste this into a cell and press Shift and Enter, but what I'll do instead is just do this in my head because it's very easy, isn't it? So we have 4 minus 1 is 3, and then 4 minus 3 is 1. So here we have it, 3, 1. Okay, so that problem is done, and I'll turn that into a comment. And I'll just space it out so it looks a little bit prettier in the comment form. Put a full stop, why not? Okay, let's move on to the next one. Given the point P, now this is a 3-dimensional point, 2, minus 1, 4. Find a point Q such that PQ is equal to 7, 6, minus 3. Okay, so what we want to do is copy down the formula again, so I can just copy and paste this and change A and B into P and Q. All right, so this will be PQ, and then I write Q minus P. Okay, but what I want to do is write the point P in column form, so I'll copy down this column, and then I'll just change things. Okay, but first comes Q, right? So let's just say Q subscript 1, and then Q subscript 2 for the next one, because that's what I'm seeking to find. And then the third one, let's call it Q subscript 3. And then we're subtracting the point P in column form. So actually I want a column matrix, and then we know what P is. It's 2, minus 1, and 4. Okay, so at this point, I can go ahead and fill in what the vector PQ is. All right, so it's this. And now all I have left is a little bit of algebra, right? So what I need to do next is add this vector P to both sides of the equation. So I'll just copy and paste the equation, and then I'll shift things around. Okay, so I'm copying this one, and then I'll put it over here. Okay, now it's easy to do this in your head, but I'll just show you. If I come down here in a cell below that and press Enter, pasting that in. Press Shift and Enter. Well, I get it in this form with the brackets around each row, right? But I can then just write matrix form. Okay, and now I can just copy this and put it up here, right? And my problem's done. But of course, you could do this in your head too. Okay, now that is a comment, so we'll turn that into a comment. And let's go ahead and move on to the next question. All right, which says, calculate the sum u plus v and sketch u, v, and the sum u plus v. Okay, so the first part of this is really simple. We'll just calculate u plus v. So u plus v, algebraically doing this in our head. 2 plus 3 is 5, and 3 minus 4 is minus 1. So what we want to write there is just 5 and minus 1. Okay, so we've got to sketch all of these. But what I'm going to do is sketch this in Mathematica for you. Okay, now I did a little bit of this calculation beforehand. So in order to not stuff this up while I'm recording, because I don't like to spend a lot of time editing, I'm just going to copy and paste this stuff over and talk about it. Okay, so copied it, and then I'll just come over here and write that. All right, so the first thing I have here is just the primitive graphics for making a vector from the point 0, 0, which is the origin, to the point 2, 3. So that will just represent this vector right here. Okay, so I'll turn that into a comment above, because I like to comment my code. It's a good idea, because when you come back later, you want to know what things were, what things you were doing. Just makes things a little bit easier. Okay, so then for the vector v, to sketch the vector v, we could do the same thing with v. All right, we could take it from the origin up to the point 3, 4, but that's not ideal here in sketching it. So I've got two forms of this here. All right, now when you sketch it, you really want to go from the, and when you're considering a sum, you want to start your next vector from the arrowhead, put the tail at the arrowhead of the last vector, and bring it across. Okay, so now the next one is from the tail or tail of v. So let's just write tail of v equal to that, starting at head of u. Okay, so that's what this next one is. You see, we start at the point 2, 3, and then we go to the point, well, that is the sum, u plus v, 5 minus 1. Okay, now the sum goes from the tail of u to the arrowhead of the sum, all right, or the arrowhead of v. But I mean, I'll show you this graphically in a moment. Okay, so we'll just say this one is u plus v. All right, now next we have some graphics commands, right? So this actually forms the graphics, but in this command I can say how I want it to look, such as dashed or thick or red or any color you like, basically. Okay, so this one says make VV dashed, basically, but that's pretty evident when you look at the code. Okay, then U plus V in thick red, and then here is basically ordinary graphics without any options, and then finally show together. Okay, so let's take off the semicolon there and display this. All right, so the one on the left here in black, that's the vector u, and then as I said, we line up the next one at the with its tail at the arrowhead of u in consideration of the sum, and then we draw the sum from the beginning to the end. Okay, so that's how we think of a sum geometrically. Now the dashed arrow that I have over here is also v, because remember you can shift these around. They just have magnitude and direction, magnitude being the length and direction being the direction of the arrow. So you can shift around these vectors. It just tells you how to get from a point A to a point B. So we can move it over to the arrowhead of the first vector. Okay, and then you can fill in the gap here and put a U going there and make a parallelogram. All right, so let's just make this a little bit smaller so we can continue on. All right, so we've done that question then. Okay, good. So let's have a look at question 3b. So now this is the same thing, but with three-dimensional vectors. Okay, so the sum then would be just adding those two together. So let's just copy this and write u plus v is equal to this one plus this one, which is, let's see, we put a 1 there because 1 plus 0 is 1, and then 2, and then 0. Okay, so there's our sum, just arithmetically calculated. And now what we want to do is plot this three-dimensionally, but I'm just going to copy out some code here. So the difference here is that we're doing graphics 3D. So graphics 3D. Now, this time I just want to do this rather quickly, so I'm just going to copy and paste a few things. So here I've got 1, 2, and then 0. So this would be the sum, but I'll also do u and v. Just paste them in here. Okay, so we want 0, 0, 0 to 1, 0, 1, and then we want from the tail of the last one, which is 1, 0, 1, up to the sum. Okay, that looks good, and they will all come out red, but that's okay. All right, so here we go, and now the good thing about this when it's 3D is you can switch views like that, so you can really get a good idea of what's going on. Okay, so let's make this smaller and move on. Of course, you can change the color of each one of those, but that involves some more writing, and I'd like to keep it simple for now. Okay, next one is question 4. Using u equal to 2, 3, and v equal to 0, 2, calculate these vectors minus 2u, u minus v, 2u plus a half v, and sketch these. Okay, so the sketching part should be easy. I'll just be able to copy and paste the code that we have from above, and I'm just going to get rid of this and bring this across. All right. So let's go ahead and calculate these. So this time I'm going to put these into memory and just get the computer to do this, even in the same cell. So I'll put semicolons after these. Except in this case, I think I'll call this A and B because I probably want to keep U and V as is without changing too much code. Okay, so then what we're doing is calculating all of these things, but I'll have to change the letters to A and B. Right, but I mean I should discuss the what's actually going on in the calculations first before I press the button. Okay, so this is scalar multiplication. So in other words, what this will do is take the minus 2 and multiply it by each of the entries in this matrix here. Okay, this here will just take the difference of each of them. This will do a scalar multiplication on each and then add the result. Okay, so let's press the button. Hang on, let's just write matrix form so it comes out looking the way that we want it to, and then I'll press the button there. Okay, so minus 2a, that comes out as expected. The difference, that looks right, and so on and so on. Okay, now we want to sketch these, but what I'm just going to do here is bring up the code that I have from here. And let's just make this very simple and just say graphics, all of those arrows. We'll take off the show because we'll just put the one thing together. So P, Q, and R together. All right, let's press Shift and Enter. Now we've got several arrows here, P, Q, and R, right? And you've got to just determine which one is which. Now, one way to do that is to just do these one at a time. For example, if I get rid of the Q and the R, you can see which one P is, right? So it's the one that goes down and to the left. Okay, so I'll put those back in. And remember, you can move these around, right? You just have to change where you start. So if you wanted to start from the end of this arrowhead, you just make the end point of this arrowhead be the beginning of this rather than 0, 0. And you'd have to add that to both the beginning point and the end point. Okay, great. So let's move on and have a look at the next one. So next we're calculating the norms. Now I believe I put those in as A and B in memory there. Okay, good. So what we want then is the norm of A and the norm of B. Now remember what that is. So I can just call on A and B, okay, so that we could view the hand calculations here. So then the norm of A would be the square root, so SQRT, and it's the first one, so 2 squared plus 3 squared. Okay, and that's the norm of the first one, and then similarly the norm of the second one would be the square root of the sum of the squares of 0 and 2. Okay, but I also could do this with the explicit norm function. So I could just write norm, and then I put in the vector A, and then likewise norm vector B. Now, the next one, calculate the unit vectors. So the unit vectors are just the vectors of length 1 having the same direction. So in other words, we just have to divide by the norm. Okay, so let's just do this with code. So we're just dividing by the norm in this case. So in other words, A divided by norm of A. Okay, so this gives us the unit vector, but we'll display this in matrix form. And similarly, we could just do that for the second vector, which we've put into memory as B. Okay, good. Now let's have a look at question 5. The vector A has magnitude 10 and direction pi on 3. Write A in component form. This kind of tells you that it's two-dimensional because otherwise you would have two angles, right? So we're going counterclockwise from the x-axis when we discuss that direction. Okay, so that's basically the angle from the positive end of the x-axis is pi on 3. So let's say that A is equal to, now I just want to clear the memory here, so go evaluation quick kernel, just put, we'll think of it, I'm just going to write it as a row here. So let's just call it P comma Q, all right, so I don't have to introduce subscripts. Next, what we have is that the angle, let's just work with the cosine here. So the cosine of pi on 3 is equal to P over That's right, so P over the magnitude, which is 10. Okay, so rearranging this, what we have then is that P is equal to 10 cos of pi on 3. Now we can do something similar with the sine, because the sine of pi on 3 will give us Q over 10. All right, so then what we can do is see that P comma Q is equal to 10 times cosine of pi on 3. And then the second component, the Q, is 10 times the sine of pi on 3. So just change the cos into a sine. All right, now you can remember this with the famous triangle of angles 60 degrees and 30 degrees, or pi on 6 and pi on 3. Okay, you can also just calculate it. So we may as well just go ahead and calculate this. So come into a new cell here, because all of this I intend to be a comment. All right, so let's just press the button. So we have 5 comma 5 root 3. So in other words, this one is root 3 on 2, and this one here is 1/2 from the famous triangle that I don't want to draw right now. All right, so that's the vector in component form. Now, if you wanted to write this as a column vector, you can just, this is 5 followed by 5 root 3. And so that's our vector A. Okay, good. Let's have a look at the next question. Find the magnitude and direction of the vector B, which is 4 times I hat minus 3 times j hat. So these are unit vectors, and what this means is it's just the vector of magnitude 1 that's in the direction of the x-axis. Likewise, this is the vector of magnitude 1 that's in the direction of the y-axis, positive end of the y-axis. Okay, but this is easy just to read because these are placeholders essentially. So I can just put, I wanted to paste this one, but I can just put 4 and then minus 3 there and write B equals this. Okay, so we're just finding the magnitude and direction of this one. So what that's going to mean is the norm of the vector B, and then we need to calculate the angle from the positive end of the x-axis. Okay, so now this one goes down because it's minus 3. So we're thinking of the base of the triangle on the x-axis but coming down. So that would be a negative angle, or you can take it as a positive angle going counterclockwise from the positive end of the x-axis. Okay, so the norm is very easy. We can just write norm, or you could just take the square root of the sum of the squares, which should give you 5. So norm of B is the magnitude 5. All right, now the direction, the easiest way to do this from here is to use the tangent, all right? So the tangent of that angle is equal to minus 3 over 4. So what we have is tan, and now we'll just put the angle as A, so is equal to opposite, which is minus 3 over 4. But what we want to do here is take the inverse tangent, which is called arctan. So make this a comment here, and we'll just say, we'll just write angle equals arctan minus 3 over 4. Okay, now that gives us negative arctan of 3/4, but you probably want the numerical value for that, so we can just put an n in front. Now it gives it in radians by default, but you could change that to degrees. Okay, so if we want to take this from the positive end of the x-axis, we would add 2 pi to that. So I'll just write angle plus 2 pi And then, so that's 5.639 and so on radians from the positive end of the x-axis counterclockwise. And that's the direction. Okay, consider these three-dimensional points. Determine the lengths of the sides of the triangle ABC. Okay, so what we need to do is form two vectors. So I'll pull up the palettes and show you how to get the arrow. So here we go, there's the arrow. Okay, and I'll just write an AB. Close this now. So this, remember, is B minus A. And what we have here is, and I'll just write this in row form, it'll be easier. And I'll put in the curly brackets because I'm going to make this code soon enough. Okay, so B minus A. So let's see, we have 3, 3, 2, and then we're subtracting 5, 5, 1. Okay, and like I said, I'm going to do some code here. So let's just take the difference here with the computer. So we get -2, -2, 1. So let's come back up here into our comment and put that there. Okay, now similarly we want another side. Okay, so we can also put, let's see, AC will be C minus A, and now I just have to take the coordinates of C and put them here, and then take that difference so -4, -1, 3. Okay, good. And then now we want BC. So BC is C minus B. And this is this one minus B, which is here. And then we can just get the computer to do that arithmetic. And we have -2, 1, 2. Okay, good. Now we just need to take the magnitude of these. So next we'll just write norm of this one. Okay, I can suppress these arithmetic differences here with a semicolon. So I've got norm 3, and then let's do the same for the others. Okay, and I'll just copy and paste each of these vectors in. I'll take the last one and paste it there as well. Okay, so we've got sides of length 3, the square root of 26, and 3. Okay, so for the last question here, we've got to determine the angles of the triangle ABC. For this, we're going to use the cosine rule, which I've written down here. But I've rearranged it so that we can use that to immediately get the cosine of the angle C from the side lengths C and A and B. Okay, so what we want to do then is come up here and put into memory A, B, and C. Lowercase a, B, and C is the side lengths. Okay, and so now I want to call, let's see, this one was AB. Okay, now let's call that lowercase c because that will be opposite the angle C. So I'll call this lowercase c there. And AC was the next one, but that's opposite the angle B, so I'll call that lowercase b. And then finally BC, I'll call that lowercase a for the same reason. It's opposite the angle uppercase A. Okay, so let's put that into memory. Good, and so now I can come down here and use my cosine rule of this one. And so let's go ahead and have a look. We probably want the numerical value, and let's keep that in radians. That's the default setting. Okay, now, so this is the angle C. All right, but likewise, we can get the other angles just by changing the names of these. Okay, so next, if we want the angle A, then this would be A there, and then we would have B and C there, and then B and C here. Okay, and we have the same thing, which actually makes sense if you think about it, because we have two equal sides. Okay, now to get the last one, we just take pi minus each of those, because the sum of the interior angles adds up to 180 degrees, which is pi. So we subtract each of these because fortunately they are equal. And there we have the third angle. All right, well, that's all for now. Thank you for watching. Bye.